Okay, what I'm going to do today is explain a few of the machines that we have in the machine shop. These are mostly available to the upperclassmen, but what I'd like to show you guys is what these different machines do and their different operations. This particular machine here happens to be a Bridgeport milling machine. It has 3 axes, X, Y, and Z, which is a drill press type of an axis. And this can perform several different operations, one being a milling operation where we can remove stock with a end mill, which is a 4-flute or a 2-flute end mill. The part essentially gets put into the vise on a set of these 2 devices here. These are called parallels, and they do exactly what the name implies. It keeps the part parallel in the vise. So the piece goes in the vise and we tighten it up, and then I take my end mill and I load it into the spindle through what's called an RA collet that holds the tool. So we'll put the end mill in, tighten it up. And then what I'm going to do is to raise this handle here. This is called the knee, and it essentially raises the whole entire lower casting with the vise up to my cutter, so we can have a minimal amount of space in between the cutter and the part. Okay, hold on, shut down. Okay, one of the most important things in the machine shop is to have your safety glasses and no long hair or jewelry hanging off in any fashion whatsoever, because it can have a tendency to get wrapped into the cutter and do some damage to yourself. So we want to make sure that we are plenty safe at all times. Safety glasses on, and I'm going to perform a milling operation. Machine on. Give it a little more RPM. RPMs are approximations, estimated approximations. Now I'm going to raise the knee until the cutter touches, so I can take a depth of cut. I'll come off the part, and I'm going to come up about 50 thousandths, 0.050. And now I'm going to make my cut. Nice steady feed rate, right across the part. You can see the chips coming off of it. And it's milling out my little space, both X and Y, that I want to make. Just like so. Off the part, and that's our milled surface on the flat side. Now the end mill can be used for 2 different fashions. One is the one I just showed you, and the second is going to be to use the periphery of the end mill or the side of the end mill, which we bring down like that, machine on, and then we can bring it in and touch the side of the part, and then we can cut and traverse across the end of the part to make it square relative to the vise. Okay, so that's 2 operations that are performed with an end mill. Okay, stop. Okay, so the next thing I want to do is I'm going to put in a 3/4 inch drill to pass it through the part. So I need to change out my end mill again. Remove that. Remove the collet. Put the correct size collet in for a 3/4 inch drill bit. Just like that. And now I will guide it over the part into the middle. Okay, and the machine on, so being such a big drill, we're going to have to run this relatively slow, about 500 RPM. We're going to use a little bit of coolant on it to keep the chips from sticking to the drill bit. And I'm going to peck drill. Come down and break the chip and break the chip. If I continuously push down on the drill, you're going to see a long chip that starts to develop, and this can get into a dangerous situation where it could actually hit you or cut you. So what you want to do is to have to break the chip to be able to break the segments into little pieces that are safe so that nobody ends up getting hurt. Remember, safety is number one at all times. Right through the part, and there's our completed hole. Okay, so what we've got here is a 1640 engine lathe. Means 16-inch diameter I can put in here, and a 40-inch long piece is the max that can fit in this lathe. It's called an engine lathe. And we've got our cross slide up top, which controls our tool depth of cut. Up on top of that is the tool post holder with the tool itself, and it simply drops down onto the dovetail and locks in. It has to be at a certain height at all times relative to the center line of the spindle. And this controls the depth of cut, how deep we're cutting into the part. And then I've got the carriage, which will feed automatically along the longitudinal distance, which will turn the outside diameter, like I'm going to demonstrate. So I've got a 3-jaw chuck. I open up the 3 jaws with the chuck key wrench, put my piece of stock in. Tighten it up. Now RPM for this, it's about 2.5 inches in diameter. So we're going to go with 540 RPM plus low. Turn the machine on over here on the side of the carriage. Whoop, it helps to have it on. And there we go. And we're starting to spin the piece of material. Now the big difference between the lathe and the Bridgeport is we're doing a lot of round stuff in the lathe and mostly square stuff in the Bridgeport. However, we're spinning the material here in the lathe, whereas the Bridgeport, we're holding the material and we're spinning the tool. So they're kind of opposite each other what they're, on how the operations are performed. So the first thing I'm going to do is to take a face cut or an end cut across the part to square it up, make sure that it's square from the saw cut. So we go in and we take off about 10 thousandths and we turn the face until it's nice and smooth. Directly back out with the tool. So now I've cut the face and that's square. Now I want to take a cut on the outside diameter to true it up and make it run round, nice and true. So I come over with the tool, I touch the stock, feed in about 10 thousandths, and now I'm going to use the automatic feed on the carriage to have the carriage move all by itself at a programmed or set feed rate, which is in inches per revolution. So every time the chuck comes around one time, the carriage advances a certain distance given what the handles are set up at. And right now it's set up to about 8 thousandths per revolution, or IPR. And then we make our distance cut, and this is called the Z direction. We'll shut the feed off, bring the tool back, and now we've got a piece of round stock that is now squared up on the face and got a true diameter. Okay, so the next thing I want to do is I'm going to use the same drill that I used in the Bridgeport. I'm going to now use in the lathe to drill through the center of the part. I'm not going to drill all the way through it, but I'm going to drill into it some just to demonstrate how the drill works. We've got a drill chuck, typical drill chuck that you see on a drill, a little bit bigger than normal. We tighten that up, tighten the drill with the chuck key wrench. Get the drill close to the end of the work. Then we'll lock in the tailstock, which is this big casting device. Okay, our RPMs are going to be 325 RPMs. We're going to slow it down a little bit this time. Let's take the turning tool off. We don't need that. Machine on. And now I've got some coolant. I'm going to put the coolant on to help keep the chips from sticking to the drill and to keep it cool. And here we go. Just like on the Bridgeport, I want to do a peck drill. Otherwise, I'm going to again end up with very long chips that have a tendency to come out, and they end up getting wrapped up around the drill, and they just make a mess in general. and it's not a safe thing to do. So what we want to do is just keep breaking the chip into small little pieces. We go in about an inch, come back out, and there is our hole that is drilled to size through the center of the part, right on center. Okay, so what we've got here in the back room of the shop is a vertical bandsaw. It's got a 1/2-inch blade on it. It's for cutting all different types of materials. So what I'm going to do is demonstrate on cutting a small piece of aluminum. Okay, so I've got the guide needs to be set so that it's up and down so that it stabilizes the blade. We want it just a little bit above our material. Turn the machine on. And then we just take and we can feed it by hand. Cut different shapes out of the bandsaw. That happens to be a circular piece. We can do flat cutting and so on. Again, this is very important safety-wise. You keep your hands out of the way as much as possible and try and get the part through without getting your hands too near the blade, and you should come out with a successful part. Okay, so what I've got here is called a shear. It's basically a big paper cutter for cutting aluminum and thin pieces of material. And essentially it's very simple to operate. You put your piece of stock in the shear on one end, and then you push it through to your set dimension or your scribed mark that you're going to put on your part, up to the blade that's inside. You guys can't see it. We get it lined up, and then we essentially just press down on the foot brake, and that ends up shearing the part and cutting off the piece of material that we need, that we had cut off. Okay, and what we have here is called a box and pan brake. This has different shoes that sits in segments along this rail, and this is designed to bend sheet metal, sheet aluminum into right angles or to form a box. Essentially, the shoes are lifted up, part is slipped into a given dimension, bring the shoe down and clamp it. We lift the leaf, and we can then take and bend a piece of sheet metal or sheet aluminum into a nice right angle. Okay, so what we've got here is a drill press. It's a little less sophisticated than a Bridgeport. This is just simply for drilling holes. There's no milling operations that can be performed with this. You've got a simple drill chuck. Open the drill chuck with no key. Drill bit goes in, tighten down the jaws, and that locks it in place. Piece of material goes into the vise. We close up the vise, clamp it tight. And then we've got a given dimension that we're going to follow. The machine goes on. And we're going to center the drill right over the hole that I want to, the spot that I want to drill. I'm going to put a little cutting fluid on it. I'm going to hold the vise tight. And then come down with the drill bit. And just like on the Bridgeport, we're going to peck drill. We're going to break the chips, and we're going to go right through the part. Just like so. Machine off. Clamp opens up. Part out, and there's our drilled hole. Okay, so what we've got here is a drill press that's similar to the one downstairs. It's not as sophisticated as the one downstairs. And we've got a table that has a rip fence on it. It's got adjustable stops on it, so you can put a board up against it like that. Set the stop, and we can come in to a certain distance. going to demonstrate is drilling a hole in a piece of material. So we lay the part flat up against the fence. It's nice and tight. And in the center of the table is a through hole. We don't want to be drilling into the table, so we want to make sure that the chuck is centered over the center of this opening. And by loosening the lock on the back, we can rotate this. And we can also raise and lower the table up and down. So I'm going to raise the table so that it's closer to the drill chuck. Bring it up about there, and lock the table. Moving. That. And then we'll take our piece, lay it in, up against our stop. And then we'll bring in clamps along the table to clamp the part down tight. That's not going to clear it out. Okay, so I'm going to put the drill in the drill chuck. I'm going to tighten the chuck by hand. Take the chuck key wrench and we will tighten up the chuck. Okay, and then we can turn the machine on and off. We're going to bring the guard down, the safety guard. And we're going to put that around the chuck to stop any of the chips from injuring us. Okay, now to turn the machine on and off is this red switch here with the yellow safety device that's been plugged into it ahead of time. We put the safety key in, and we can open. As you guys can see, we've got really fine particles that are coming off of that. So there's no need to break the chip like I did down in the machine shop. We can just continuously drill and go right through the part without interference of chips. Okay, what I've got here is a belt sander. This is a vertical belt here, and we've also got a disc that sits on the end of the motor. So we can do two different types of sanding. And I'm going to demonstrate that by putting the part here. We're going to rest it on the table and we're going to feed it into the belt. We do not want to hold the material in your hand, and you don't want to be feeding this in like this against the belt. The belt turns this way, and you don't want to be feeding it up this way because it's going to take and jam the part down onto the table. So you want to hold it this way, and then the belt comes down this way, and you can successfully radius the part or sand the corner of it, put a 45 on it or whatever. So I'm going to demonstrate that now. And then I'm going to come over to the end of the disc, and I'm going to show you how we can do a radius on that too. Okay, this is called a scroll saw. This is for doing very tight corners or making like a jigsaw piece. And you can only cut thin materials with this. You can cut aluminum. This happens to be a piece of basswood that's thin enough that we can cut out different shapes in it. So this is about 1/8 of an inch thick. I wouldn't go any thicker than that. We've got a guide on the bottom. It's going to help to hold the material down as it's being cut. and you want that to drag just across the top of the part just a little bit, and that's adjusted by this screw over here on the side. We loosen it, and we can move the guide up and down. Bring your piece of material in, bring the guide down to the top of the material, and then we can lock down our guide. And from there, we're going to turn the machine on. And we've got a knob, a speed adjustment knob up top. We can speed up, and we can slow down. So we're going to run it about halfway between fast and slow. And then we can take and feed in our piece of material slowly. Okay, so you can end up with a piece like that. It's like a shark's tooth or something. But you can cut complicated curves and different angles with this type of a machine. Okay, we've got a hand drill here. This is a 3/8 drill chuck. It can take no bigger drill than 3/8. We've got our battery pack. Simply plugs into the bottom, slides in, and then we've got operation. You've got your trigger here for forward, and you've got your reverse switch here to go backwards. Slide it back and forth. To load the drill bit, take one out of our case, and you put it into the drill chuck, and you simply hold the chuck with your hand and pull the trigger going forwards, and that tightens up, and you grab this tight with your hand and just give it a quick shot, and that will tighten up the drill into the chuck. To get it out, go into reverse, again hold the chuck, you spin it in the opposite direction, and the drill comes right back out of the drill bit comes out of the drill. Put it back in the case. Everything goes back in as soon as you're done, so we don't lose anything. And you're good to go. What we've got here is a Dremel tool. This has a collet. It's up front. You can turn by hand, loosen it up, and you can pick any one of the tool bits that we're going to need. We've got stones, and we've got different types of cutters. Pick the correct one that you're going to need. That goes into the chuck, and you press this little button here, which is a brake, and you hand tighten the chuck by hand. Snug it up tight by hand, and that's locked in. To turn this on and off is the switch right here. And then we've got our speed adjustment down here. Make fast and slow, whichever RPM's needed. We've also got this device here, which is kind of like a drill press again. And you can put the chuck in, or the Dremel tool into the holder and lock the nut down, and that will hold the whole entire Dremel assembly in the fixture. And then from there we can turn it on, adjust our speed, and you can go in and hold your part, and you can do whatever you need with the end of the Dremel, so it's holding it for you. You can also do, by loosening this little nut on the back, we can rotate this 90 degrees like a drill press. Lock it back up. And again, you've got operation to go into a hole, or if you wanted to actually drill a part, you can put a drill bit in here also.